And welcome back to the new video with this channel. So today we'll be solving a problem which is modify graph edge weights leetcode 2699 problem. So let's see the problem statement. So problem is saying that we have given an undirected graph, undirected weighted corrected graph containing n nodes labeled from 0 to n minus 1 and an integer array edges which is showing ai to vi and the weight is wi. It means if I want to go from ath node to bth node, then the weight of that particular node will be wi. Indicate that there is a edge between a to b and the weight is w. Some edge have the weight of minus 1, wi equals to minus 1, and some other edge of the weight of greater than 0. It means either it can be minus 1 or it can be greater than 0. The weight, I am talking about the weight. Your task is to modify all edges with the weight of minus 1 by assigning the them positive integer values from 1 to 2 into 10 is power 9, so that the shortest distance between, this is the important line, the shortest distance between the node source to destination becomes equal to the target. If there are multiple modifications that make the shortest distance between source to destination equal to target, any we can return any one of them. So return an array containing edge and distance. Okay. So notice you are not allowed to modify the weights of the edges with initially positive inter. So it is a important line. We can't modify the weight of the edges. Okay. So let's see this example. Example is very simple. uh, we have to create, firstly we have to create a adjacency list to make this graph. It means 4 to, if I want to go from 4 to 1, then the weight is minus 1. 4 to 1, then the weight is minus 1. Don't see this these weights 1 1 3 1. We created these weights after the modification, but initially it was minus 1. If I want to go from 2 to 0, it also is minus 1. 0 to 3, it is also minus 1, and 4 to 3, it is also minus 1. Now we have to create, if I want to go from source to destination, which is 0 to 1, so we have only one path to go from 0 to 1, and all weights are minus 1, you can see here. Now I have to modify the weights because our target should be 5. So the modification can be 0 to 3, it can be 3. 3 to 4, it can be 1, and 4 to 1, it can be 1. So the final sum of these this path, the weight of this path is 3 plus 1 plus 1, which is 5, which is equal to target. So it can be a desired answer. So the graph shows a possible modification to the edges, making the distance from 0 to 1 equal to 5. Okay. So the weights can be changed, like 0 to 3, it can be 1. 3 to 4, it can be 3. So it is only depend on us. Let's see this. The source is 0, destination is 2. So this is only a single path and the target is 5. But here the the weight of this particular node is 5, because we only can change minus 1. If the weight is minus 1, then we can change, otherwise we can't change. So the weight is already given, which is 5, which is not equal to target. So we have to return the empty array, so that's why we are returning empty array. So let's also see this source to destination 0 to 2. So 0 to 2, so we have two paths. First path is 0 to 1 and 1 to 2. So the weight of this path is uh, okay. So let's see the initial weights. 0 to 1 weight is 4, 1 to 2 weight is 3, and 2 to 3 the weight is 5. So these weights are initial weights, and 0 to 2 weight is minus 1. After that we are changing this weight to 1. Now let's see 0 to 2 generally possible path. It can be a possible path, so the weight will be 4 plus 3, which is 7, which is not equal to target. So we will not see this weight. And another part can be this one, and the weight is 5 plus this was a minus 1. So now we are changing minus 1 to 1, so that it can be 6, and which is equal to target. So it can be a desired answer. So that's why we are taking 5 plus 1 equals to 6, and this can be our answer. So you can see the uh, constraints are also good, so we can use the shortest path algorithm firstly. So let's see the approach. So approach is very simple. Let's do it. Yeah. So this was the example. Source equals to 0, distance equals to destination equals to actually 1, it should be 1, and target equals to 5. So if we have given this example, like if I want to go from 2 to 3 and the weight is minus 1, okay, so we have two paths from for go to 2 to 3. So it can be, first part can be this, which is 1 plus 1 2, and no one weight is a minus 1, so we can't change the weight. This weight is minus 1. I'm not talking about this. I'm talking about this path. So 1 plus 1 2, which is less than my target. So there is a way to go from 2 to 3, which is less than my target. So in that case, if initial distance is less than target, so we have to return a empty array, because I have the path that is the shorter path, and also it is taking a shortest distance. So that's why in that case I will return the empty array. So this is the first condition. If my initial distance is less than target, so I have to return. So for that, for finding out the shortest path, I have to use the Dijkstra algorithm. So it is a basic problem that if I want to go from particular road to particular road and we have to find the shortest path, then in that case I can use Dijkstra or Bell's marks in some cases. If initial distance इक्वल टू टारगेट, इट मीन्स कि यार मैं उस नोड पे पहुंच चुका हूँ जहाँ पे मेरे को टारगेट के इक्वल पहुंच चुकी है नोड, तो वी हैव टू चेंज ऑल माइनस वन टू इनफाइनाइट, बिकॉज मेरे को जो पाथ चाहिए था वो मेरे को मिल चुका है। अब बची हुई नोड माइनस वन वाली नोड को मैं इनफाइनाइट से शो कर दूंगा, जो कि मेरी पाथ में मतलब बैरियर नहीं बनेंगे, ठीक है। अब एल्स कंडीशन क्या होता है, चेंज माइनस वन टू वन, ठीक है, इनिशियली माइनस वन से वन को चेंज करेंगे और बाद में देखेंगे। टू कैलकुलेट न्यू डिस्टेंस अगेन यूज जैक्स एल्गोरिथम। इफ न्यू डिस्टेंस इज लेस देन इक्वल टू टारगेट, तो इट मींस दिस इज अ गुड कंडीशन, इज इक्वल टारगेट इक्वल टू ट्रू कर देंगे, एज में ये ऐड कर देंगे। सो लेट्स सी द dry run for this problem. So this was the example that we have given, first example. So let's zoom out. Yeah, source equals to 0, destination equals to 1, and the target equals to 5. So firstly we have to create an adjacency list. If I am converting this minus 1 to 1, so the adjacency list will be something like 4 to 1, the weight is 1, and the 1 to 4, the weight is 1, and we can write also this 4 to 3, the weight is minus 1. But we are not changing this minus 1, that's why I am not writing here. You can write also. So now we are changing this weight minus 1 to 1. Now again we are checking like 0 to 2, the weight is 1, and 2 to 0, the weight is 1, and these are the adjacency, previous adjacency list you can write here. So just for writing adjacency list, it's a very simple. Now I am changing this minus 1 to 1, then again I am changing this minus 1 to 1. Now I've changed all minus 1 to 1. Now I'll go from 0 to like uh, uh, by doing this I will check like shortest path. If I am going from source to destination, then I have to find the weight, also the sum of the weights also. Now here you can see I have converted all the minus 1 to 1. Now I have to go from source to destination, which is 0 to 1, and I will sum out 1 plus 1 plus 1, this is 3. So what I will do, rather than changing this minus 1, I have changed this minus 1 to 1, but rather than changing this minus 1 to 1, I am changing this minus 1 to 3. We have to do, we have multiple choices. यार माइनस वन को मैं वन से टू इंटू टेन इज पावर नाइन में कन्वर्ट कर सकता हूँ, तो सबसे लास्ट यही वाला बचा था, ठीक है, इसको चेंज करना। सो नाउ आई वांट टू चेंज दिस माइनस वन टू थ्री। if I will change now, my sum will be 3 plus 1, which is 5, which is equal to my target. So is equal target equal to true, and rest minus 1 को मैं इनफाइनाइट में कन्वर्ट कर दूंगा, so that कि यार मेरे को मल्टीपल पाथ्स ना मिले, ठीक है। So that's why I am changing this. Now let's see the code for this, and code is very simple. Firstly, I am declaring the infinite value is equal to 2 into 10 is to power 9. Now I am building a adjacency list. So creating a adjacency list is very simple. It's an untitled graph, so दोनों side adjacency list बनेगी. So it's a very simple. Now we are computing initial shortest path for source to destination. Source to destination के लिए मैंने एक डायरेक्शन नाम का एक फंक्शन बनाया, ठीक है, और मैं चेक करूंगा कि यार इफ मेरी इनिशियल डिस्टेंस इज लेस देन टारगेट है। सो इन दैट केस आई टोल्ड यू अबाउट दिस, यार इनिशियल डिस्टेंस लेस देन टारगेट है तो मैं कभी पहुंच ही ना पाऊंगा। सो इन दैट केस आई कैन रिटर्न अ एम्प्टी अरे। नाउ आई विल क्रिएट अ बूल इज इक्वल टारगेट, ठीक है, अगर ये इनिशियल डिस्टेंस इक्वल टू टारगेट हो गया, ट्रू रिटर्न कर देगा, ट्रू रिटर्न कर देगा, मेरा चीज बन जाएंगी, ठीक है। Now I'm going in this and I'm changing like if this is equal target, then I will change all the values, all the minus 1 to infinite, otherwise I will change all the minus 1 to 1. Now if this is not equals to target, then in that case I'll create a Dijkstra through finding out the new distance, and then I will check like new distance is less than equal to target. In that case, is equal target equals to true, and I will add up this distance in my answer, and finally I can return. Now this is a very basic condition like for creating a Dijkstra algorithm. Dijkstra algorithm में क्या चाहिए, क्यू चाहिए होता है, डिस्टेंस चाहिए होता है, और मैं कभी कभी विजिटेड एरे का भी यूज कर लेता हूँ. बट हेयर व्हाट वी आर डूइंग इज, अगर मेरे को सोर्स से सोर्स को ले जाना है तो डिस्टेंस क्या होगी, जीरो होगी. ठीक है, तो मैंने ये प्रायोरिटी क्यू में जीरो को सोर्स के साथ डाल दिया. अब मैं जब तक के लिए क्यू एम्प्टी नहीं हो जाता तब तक के लिए कंडीशन चेक कर रहा हूँ. आफ्टर दैट आई कैन रिटर्न माई डिस्टेंस ऑल्सो. सो दिस वाज द सिंपल कोड यू कैन सी हियर. बेसिकली कर क्या रहे हैं, ठीक है, मैं कंडीशन चेक कर रहा हूँ कि यार मेरी इनिशियल डिस्टेंस लेस देन टारगेट हो जाती है. सो इन दैट केस आई हैव टू रिटर्न द नल एरे. ओके, सो सेकंड कंडीशन दोनों डिस्टेंस मैच हो जाती है तो मैं क्या करूंगा, ट्रू मार्क कर दूंगा. जो भी बूल इज इक्वल टारगेट को ट्रू मार्क कर दूंगा, और ऑल द माइनस वन को क्या कर दूंगा, इनफाइनाइट से चेंज कर दूंगा, सो दैट कि यार माइनस वन ना हो, अब चेंज ना हो पाए, बहुत बड़ी वैल्यू पे चेंज हो और उनका सम कभी पहुंच ही ना पाए. ठीक है. नाउ माय थर्ड कंडीशन, इफ द some initial distance is greater than target, in that case what I have to do, कि यार वो पाथ तो हो ही नहीं सकता तो फिर रिमूव कर देंगे पाथ. सो दीज थ्री कंडीशंस आर देयर, and it's a very simple tax algorithm, so you can see this also. So this was the code, and if you find this helpful then please like, share and subscribe. तो तक के लिए बाय, मिलते हैं नेक्स्ट वीडियो.